Okay, so after looking at it for a little bit, I think I'm just going to dive straight into some homework problems real quick and give you some options. I think that the first video really covered pretty much all the examples and laid it out really well. If anyone's having any trouble, feel free to let me know. Absolutely, just like anytime. But for this video, I'm gonna roll through a couple of quick example problems. They shouldn't take very long, and then I'm gonna put you to work on your homework, which is on page 472, 1 through 28, and hopefully it all goes pretty smoothly. And then the next time I'll see you is in lesson 8.2, which should have a very similar feel to it anyway. Problem number 2, we're taking a look at this. This is just a polynomial. Now, the fact that this polynomial is out of order makes a big difference. So we're in ascending order rather than descending order like we should be. So this is actually my leading coefficient. Because the leading coefficient is negative, I have a polynomial, negative leading coefficient. The limit as it approaches infinity is negative infinity. For number 4, which is the next problem on our list, this will be a polynomial. You could sit and multiply this out. This whole thing would be cubed, so it would be multiplied to itself 2 times. And if you work that all out, you would have some sort of giant mess. But the real truth of the matter is that in the end, it doesn't really matter, because you'll have a big old polynomial, and because this is positive, it'll be a positive leading coefficient on this big old polynomial, so the answer will just be infinity. So this looks like it could be a lot of work, but it's really not much work at all. Number 8 is next on my list. So I'm looking at the degree or the largest monomial on top and the largest monomial in the bottom. The degree of the top is less than the degree of the bottom, which means that our denominator is going to take over. And remember, when the denominator takes over and the numerator loses, if the denominator wins, the numerator loses. And if with a very large value in the denominator and a very small value in the numerator, which means we're headed toward 0. When the numerator is small and the denominator is large, 0 is our solution. Number 11 is the next problem on my list. So on number 11, I have an E. Now I know that E will win. This little 2 out front is inconsequential. This negative 3 does make a big difference to the problem, which is why I wanted to point this out. E will take us to infinity, but because I'm multiplying it by negative 3, because it's negative, just like the negative polynomials, it'll actually go to negative infinity. Now, if this was a negative power on my E, it would be 0, regardless. Whether this is negative or positive out front, my answer would be 0. But because this is positive x up here, it goes to negative infinity. I'm going to leave these bottom ones down here, but I'm going to come in and replace the top 2. I'd also like to look at problems 18 and 27. So problem 18 gives us 2x over e to the 3x, and problem 27, which is the real doozy of the group, gives us the ln of 2x plus 1 over the ln of 3x minus 1. That's the fun one. But let's focus on 18 next. I have an E, so that means that the E is going to win. The E is in the denominator, so my denominator is going to be much larger than my numerator. So again, I have a small value in my numerator, a very large value in my denominator, which means my my entire equation will head toward 0. It doesn't matter what the coefficient is up here, or the fact that this is multiplied by 3. It's really inconsequential. I have an extremely large number in the numerator, a very small number in the an extremely large number in the denominator, a very small number in the numerator, so they'll head towards 0. Last one, 27. So this one, I have the same thing top and bottom, ln's, which means I'm even Stevens at this point in time. So I need to take the derivative of each of them. Now, I'm going to kind of walk through this, but there's a much quicker way to jump through this middle step, but I want to make sure that everyone understands what we're doing. So for those of you who are high flyer, fast thinkers, we're going to jump past this middle step, but I'm going to do it right now. So the derivative of the ln of 2x plus 1 is 1 over 2x plus 1. And the derivative of the ln of 3x minus 1 is 1 over 3x minus 1. It's just the junk that's inside. So it's 1 over the stuff that's inside. And it's actually, it's the derivative of the inside over the inside. So it would be 2 over this and 3 over this. I suppose I should leave it in, just for the sake of the process. Okay. Then what happens is these both get flipped and multiplied together. So we're gonna flip the top one, or we're gonna flip the bottom one and multiply. So I end up with 2 times this, 3x minus 1, over 3 times this, 2x plus 1. Which really cruises forward into, at this point in time, I'm good to get rid of that next one. 6x minus 1 over 6x plus 1, or minus, sorry, 6x minus 2 over 6x plus 3. Now we can start doing derivatives of these. So we're even Stevens again, right? We don't have a winner or a loser. At this point in time, if you had some sort of squared or something going on in here, you'd have a winner and a loser here, and you'd know it's infinity or 0. But we don't, so we need to cruise forward. Derivative of the top is 6x, or is 6. Sorry, not 6x, but just 6. The derivative of the bottom is just 6. The second parts just fall away. That reduces down to 1. And we end up all the way home, right where we belong. All right, hopefully that went okay for everybody. I think a lot of you will be able to leap straight from here over to here without making that stopover in the middle. But if you need it, it certainly doesn't hurt anything to make that stopover in the middle. There is one other problem like that, 28. However, the balance is not identical like it was in this one. Some of these ln ones might stump people. Remember, when we take the derivative of an ln, any ln, let's say that I have the ln of x squared plus 4. I take the derivative of the inside, which would be 2x, over the entire inside, which is x squared plus 4. So when you derivative an ln, it's the derivative of the inside over the inside, which is what gave us these components up here, and will ultimately allow you to move forward. Hopefully the L'Hopital rule stuff goes good. Just like the previous lessons, I'll post the keys when I open this up, so it shouldn't be super difficult. I know this stuff is a little trickier than what we've currently been doing, but it shouldn't be a huge leap forward.